Okay, so 9.2. So we are going to talk today about rational exponents, and rational exponents are fractions. And so this is new. When we see this, x to the 1/2, this is the same as the square root of x. So this 1/2 means we're going to take the square root. So if I see x to the 1/3, this is going to be the cubed root of x. And then this one, x to the 1/4, is going to be the fourth root of x. And what this means is with the fourth root, that means I have to have a pairing of 4. So if I had the fourth root of 16, for example, this would be the same as 4 times 4. So my square root of 16 would be 4. But 4 is also 2 times 2, and this 4 is also 2 times 2, and now I have 4 2's, and I need 4 2's because this tells me I need a grouping of 4. So the answer to this would just be 2. So very different than if I had the square root of 16, and the square root of 16 would be 4. Okay, so this is called the index, and the index is super important because it tells you how many groupings you need. So if we see something that looks like this, this is basically saying that whatever denominator I have here is whatever my index is, and that is how many pairings I need. So n is the number of pairs needed to pull out of the radical. Okay, so we're going to write these and we're going to solve these. So this is 25 to the 1/2. So this is the same as the square root of 25. And the square root of 25 is 5. This would be the cubed root of 7. Well, if you think about 7, 7 doesn't break into any pairs. It's prime. So we're done. This is as far as we can go. Now, when I have a negative exponent, I'm still going to follow my negative exponent rules. So this becomes 1 over the square root of 9. Because this is negative, it has to move to the denominator, and because it's a 1/2, it's the square root. So when I simplify this guy, I get 1 over 3. Okay, this becomes the cubed root of 64. And if you remember in the prereq lesson, I said you've got to know some of these numbers. And so one of them would be like 4 cubed. And so 4 cubed is 4 times 4 times 4, and I have a grouping of 4, and this equals 64. So when I solve this, I end up with 4. So you're going to have to be able to do this without a calculator. Okay? So this tells me that it's going to move to the denominator. It's negative, so I have 1 over the cubed root of 64, which is 1 over 4. Now, let me review this. I don't think I did this in the prereq video, but this is super important. When we have this, there is no negative sign. There's no negative sign. When I go from this step to this step to this step, there's no negative anywhere, right? And so all the negative tells you, so negative exponent means it moves. That's all it means. So don't get stuck in saying, okay, this negative needs to come out here somewhere, because it doesn't. It just means we move it. So when we move it, it became positive. All right, let's flip this over. So now we're going to add on to it a little bit. So what we end up with is we have this, x squared to the 1/3 power. So what we know, and we just did this when we did our exponent rules, is that this becomes x squared times 1/3. And this is because when I have an exponent to an exponent, I multiply. So when I multiply, I get this. So this whole thing becomes x to the 2/3 power. So this is my rational exponent. Now, sometimes we want to solve it this way. If we have this, we can solve it here. Sometimes we want to put it in radical form. And radical form means we're going to have a radical, right? And so what happens when we do this is, remember, this tells me that this is the outside, so this is my index, and this is what stays on the inside. Okay, so this is what this looks like in radical form. So the cube comes out front, everything else goes on the inside because it's in parentheses, right? If I want to do this in rational form, this x squared, so I can multiply my exponents, so 2 times 1/3, and this is the same as 2 over 1, which we don't need to do, but 2 times 1 is 2, 1 times 3 is 3. So these two things are equivalent. So what is the takeaway on this? So the takeaway is that let me do it this one and then we'll go back up here. So this would become n to the x power all to the m. So the m is your exponent and your n is your index, and your index is what goes on the radical. All right, so I could take this guy and I could rewrite it and I could say this is the cubed root of x, the whole thing is squared. So these two things are saying the same thing. Sometimes it's easier to solve this part and then square it. Sometimes you can't square it, and so it's easier to write it this way. All right, so if we're going backwards, and what we have right here is we have something that looks like this. This is like saying x to the 2/3, right? So it doesn't matter if the power's on the inside. And this would be my rational form. And my radical form would be the square root of x to the 1/3. This is what's on the inside. The inside stays in the radical. And because this is squared, it's going to come out here and just be the square root. We never put the index on a square root, only on a 3 or higher. So again, what we did, and I should have done these the opposite direction, but what we did here is we multiplied. That's what I did here, is I just multiplied. And if I went to radical form, I know that this tells me that it's at the index is 3, and then I just kept this on the inside. So if I go this way, my index is 2, and then I keep this on the inside. Okay, let's do these down here. So here's the first thing that I have. So I'm going to look at this and I'm going to put my index first. So I'm going to have the cubed root of 8, and this whole thing is going to be squared. Now I can write it this way, or I can write it the cubed root of 8 squared. Well, this is going to give me a big number, and then I want to find the cubed root. This is a small number, so it's easier to do it this way. So if I have the cubed root of 8, this is 2 squared, because this 2 is this one. So let me do this. So this 2 is this one, and this 2 right here is this solved. All right? And I have that 2 squared is 4. Okay, so with this next one, I have the square root of 9 cubed. All right? Now, easier way to write this, I'm going to just write this over here, is I have the square root of 9, the whole thing cubed. So hopefully you see that these two things are equivalent. All right, so this is an easier way to solve this. So if I solve this, the square root of 9 is 3. 3 to the 3 power, that's where this 3 comes from. So this 3 is this one, and that is going to be 27. All right, so what do we know about this? We know that this is going to tell us that it has to move. So this is the same as 1 over 9 to the 3 over 2. And that's the same as 1 over the square root of 9, the whole thing cubed. So square root, I don't have an index, and the whole thing is cubed, which is 1 over 3 cubed, which is 1 over 27. Okay, next one that I have here is I have the cubed root of 125. Whole thing is squared. So what number multiplied by itself 3 times gives me 125? And that's 5. So this becomes 5 squared, and 5 squared is 25. All right, so this one's going to move to the denominator. Cubed root of 125. The whole thing is squared. So this gives me 1 over 25. And I'm going straight to this point because we just solved this up here. We just said that the cubed root of 125 squared is 25. Okay, now this one's kind of funky because what I have here is the cubed root of 1, the whole thing squared. So the cubed root of 1 is 1, and 1 squared is also 1. Okay, one more here. So this is a negative exponent. So if it's a negative exponent, the first thing I'm going to do is flip it. So I have 100 over 9 to the 1/2 power. Now, all I did was I took the reciprocal of what's on the inside and I made this positive. All right, so instead of, I could take the square root of both, but now I don't have that negative anymore, which is easier. So this gives me the square root of 100 over the square root of 9. Because if you remember what we did when we have an exponent on the outside, we have to distribute it to the top and we have to distribute it to the bottom. Well, we're distributing this 1/2, which makes it square root, and we distribute it here, which makes it a square root of 9. So when I simplify this, I get 10 over 3. Okay, we have one more page, and this is just kind of matching what these look like, and it kind of depends on what's in parentheses or not. So what happens with this first one is this is saying that the whole thing is going to be in the cube root, the whole thing. So this is the same as saying the cubed root of what's on the inside, so negative 3x. So if I look over here, cubed root of negative 3x is option F. All right, now on this one, the only thing that is to an exponent is the x. So what this looks like is negative 3, and now I have the cubed root of x. So this negative 3 is not in parentheses. It doesn't look like this, so it is not underneath the radical. So if I look over here, negative 3 cubed root of x, this is going to be b. Okay, this says the whole thing's in the parentheses, and the whole thing is to a negative exponent. So I end up with 1 over negative 3x to the 1/3 power. Well, we just said negative 3x to the 1/3 power is this. So I end up with 1 over the cubed root of negative 3x. And if I look over here, this is going to be option, that's negative. Oh, here we go, option H. This is positive 3x. This is a negative 3x. So it's down here at the bottom. So it's option H. Okay, so I have a negative 3. That's going to stay in the numerator. And then this x to the 1/3 is what's going to go to the denominator. So cubed root of x. It moves to the denominator because it's the negative exponent. So I have a negative 3 over cubed root of x, which is d. Gosh, I'm having a hard time matching these. I can do the work, but then I'm struggling over here. Okay, next one. Whole thing, so cubed root of 3x. So cubed root of 3x. So that one's going to be g. All right, so what's moving? Only the x is moving. So 3 stays in the numerator, and then I have a cubed root of x in the denominator. So 3 over the cubed root here. So this is going to be a. Right? On this one, the whole thing is moving. So I have 1 over the cubed root of 3x, and that is going to be c. And then the last one, only the x is to a power, so I have 3 times the cubed root of x. And 3 times the cubed root of x for this last one is going to be e. Okay, so what I would recommend is that you go back through this, and I can print you a blank one at school if you want to, as you go back through this and you redo these, because this is a perfect example of how you're going to have to manipulate these, okay?